Welcome in the class. Today in this class we will discuss the fundamental logic gates in which OR gate, AND gate and NOT gate will be discussed. So before starting the topic, it's better to recapitulate the previous discussions. In the previous class we have discussed about the basic number systems. In this we have discussed the decimal number system, binary number system, octal number system and hexadecimal number systems. And out of these four number systems, binary number systems are used in digital electronics. So the binary number systems has base 2 and it uses only two symbols, that is 0 and 1, and using these two symbols the different numbers can be derived, that is the numbers belongs to decimal number system or octal or hexadecimal. The objective of this lecture is differentiate fundamental logic gates and the truth table of fundamental logic gates. So after this lecture you will understand the basic fundamental logic gates and what are their truth tables. Introduction. A digital circuit with one or more input signal but only one output signal is called a logic gate. So this is the basic definition of a logic gate. Since a logic gate is a switching circuit, that is, it will have only one state at a time, either high or low. So if we consider the switch, then on switch is considered as high voltage and off switch is considered as low voltage. So as we know that the digital electronics is basically working in two states, that is logic 1, that is high state, and logic 0, that is low states. So logic gate is basically an electronic circuit which has more than one or more than one input signal, and after passing through logic gate there is a one output only. We start with the first fundamental logic gate, which is OR gate. So an OR gate is a logic gate that has two or more input but only one output. However, the output of an OR gate is low when all inputs are low, and output of an OR gate is high if any or all the inputs are high. So that's why OR gate is also called any or all gate. We will discuss further about OR gate with taking two inputs. So here if you see the two inputs A plus B, that is A is a input and B is a input. So the OR gate is represented as this symbol. So this is the symbol of OR gate, and the plus sign in Boolean algebra refers to the logical OR function. So the Boolean expression for OR function is A or B is equal to 0. So when we write A plus B is equal to Y, it means the two inputs are ORed, that is OR function is applied and that is equal to 1. And since we are using two inputs, so there will be 2 power 2 possible combination of inputs and corresponding output we can write here using this OR operation. So if inputs are 0 0, then the output will be 0. But apart from this, all the output will be 1, because any of the input is 1, then the output will be always 1. This is the property of OR gate. So uh, we can define the truth table, that it is a table in which we put all the possible combination of inputs and corresponding possible outputs. So if we write in tabular form, this tabular form is called truth table of the logic gate. Now AND gate. AND gate is a logic gate that has two or more input but only one out. So the output of AND gate is high only when all inputs are high. If any of the input is 0, then output will be always 0, that is low. So it is called AND gate because it will give the output only when it is output will be high only when inputs are high. That is why it is called or nothing gate. So we can see the example of this AND gate by using two inputs. So here we can see that we have two inputs A and B. So its equivalent circuit we can see here as a diode. Two diodes are used. In this circuit we can explain this or AND gate operations, and this is equivalent to a circuit in which two inputs are as a switch A and B, which are in series. So any of the switches if open means 0, then the output at Y will not be observed. Only if A and B are on, that is they are connected, the switch is on, only then output will be 1. So this is equivalent to AND gate, and this is the possible combination of inputs and corresponding outputs. So you can see that uh, when A and B are 0, output is 0, or any of the input is 0, then output will be 0. But when both the inputs are 1, then output is 1. This is the truth table for AND gate, and this is the corresponding symbol of AND gate. And as we know that A dot B is equal to Y is the Boolean expression for AND gate. So here dot indicates the AND symbol. So we can easily see that if we place the value A and B, that is input values, we will get corresponding output. So it is simply the product of two inputs, we can say. So ANDing is the property of this AND gate, and this is the truth table. So we have discussed about the logic gates of AND gate, symbol, its truth table. Now the third gate is the NOT gate, which is also called inverter gate. The NOT gate or inverter gate is the simplest of all logic gates. It's very simple because it has only one input and one output. So the property of the NOT gate is that it will invert the input, and therefore if we have A as input, then output will be A bar, that is complement of A. And this is the equivalent transistor circuit for NOT gate. Whenever A is high, the transistor will be in cutoff mode because the biasing condition is not will not be correct. Therefore, the output at Y will be 0. So every time we can see that when A is low, then the transistor will be active and all the current will flow and pass through the ground, so we will not get output at Y. So whenever A is 0, output will be 1, and when input is 1, output will be 0. So this condition is true for NOT gate only. Okay, this is a summary of the three basic logic gates. So logic function inverter will invert the input and output will be the complement of input. So it is also called inverter gate. AND gate will multiply the two inputs basically, and the output will be only 1 when both the inputs are 1. And OR gate, in OR gate the inputs are summed, that is A plus B, and the output will be 1 if any or both of the inputs are 1, and if both the inputs are 0, output will be 0. So these three uh, logic functions which corresponds to fundamental logic gates we have discussed here. Some questions based on the topic that we have discussed. What is the Boolean logics? So Boolean logics basically work on principle in which if we add 1, that is high plus high, we will get high. It's 1 plus 1 is equal to 1. And if we add 1 plus 0, again we will get 1. And if we add 0 plus 0, we will get 0. So there is only three basic logics, and correspondingly we have logic gates. So what are the fundamental logic gates we have discussed, and also what are the truth tables for AND, OR and NOR logic gates that we can answer from the discussions that we have made in the present class. These are the references for the study. Thank you.